Hello, everybody. So today we are going to look at predicting earthquakes. So in your Edmodo, you want to go to the post that says predicting earthquakes. So here's the link for the reading. Here are the practice questions, and here's my email you can send your answers to. So anyone who's been at my live lessons that actually happen in the classrooms, you've probably heard me say that predicting earthquakes isn't really an exact science. So, with a good prediction, they have to predict a few things. So they have to predict where the earthquake will occur, when it will occur, and what will be its approximate magnitude. Okay? If the prediction is good, authorities could get people to evacuate, but if the prediction is wrong, a lot of money would be lost from people closing businesses and skipping work. And of course, they wouldn't really believe the authorities next time they said that there was going to be an earthquake. So the first thing and the most important thing that scientists can predict is where an earthquake will happen. Because scientists know that earthquakes happen at plate boundaries. And history tends to repeat itself, so they tend to happen where they've happened before. Fault segments, places where earthquakes happen, fault segments behave consistently. So if a segment has frequent small earthquakes, it is going to continue to have frequent small earthquakes. If a fault segment has infrequent large earthquakes, it is going to have infrequent large earthquakes. Okay, history repeats itself. So there's an image down here. It shows the likelihood of earthquakes striking along faults in the San Francisco area. And this is between 2003 and 2032. So if we look at these percentages, they're actually quite low. All right? They're quite low along each fault line. Okay? Um, so increasing probability has to do, so the darker the color it gets, the more likely it is that there's going to be an earthquake of magnitude 6.7 or greater in between those years. So the orange ones have more of a chance of having large earthquakes than the yellow ones, okay? Now, predicting when is not really easy to do. So you would think because stress on a fault builds up at the same rate over time, that earthquakes would occur at regular intervals. But scientists still cannot predict when earthquakes will occur, even to within a few years. So there was an earthquake around Parkfield, California. It was supposed to happen within about 22 years of the previous one, and it actually came in 2004, 11 years too late. So predicting when is really difficult to do because it's not exact. So there are some signs that an earthquake could happen. So with a large earthquake, there may be small quakes or what we call foreshocks that happen before the earthquake. So they can happen a few seconds to a few weeks before the major earthquake, but foreshocks are not really useful for predicting large earthquakes. All right? And many quakes do not have foreshocks, and small earthquakes are not always followed by a large earthquake. Okay? There's also ground tilting. This is caused by the buildup of stress in the rocks. This could happen before a large earthquake, but doesn't always. There's a fluctuation of water levels in wells because the water may move into or out of the fractures before an earthquake. But again, all of these are not really certain ways to predict an earthquake. The difference in arrival times of P waves and S waves may decrease just before an earthquake. And then they also have animal behaviors, and then they do have things that can happen to reduce the damage. So if seismometers detect P waves a few seconds before the S waves, they can have computers that are going to shut down gas mains, electrical transmission lines, and just shut down certain things, because in an earthquake, if you have a gas main and it explodes or it's damaged, that could cause a really bad fire. So make sure you complete your questions and turn them into me.